all of my sessions are recorded, and you should be seeing a copy of my screen.
Yeah, I do see your screen.
A
I see
copy.
my work.
Yeah, the document that you sent me, and this over here allows me to write whatever I want. So it's the equivalent of being kind of in person with paper and pencil.
Okay.
All right, so let's look at this document on the left.
Not the best quality, sorry.
That's all right. Let's see. The first one looks like you did it just fine.
Yeah, I think you want to start off with 5 where I haven't started it all clean.
Sure.
Okay.
Start off wherever. Okay, when you get a problem like this, you can be pretty sure that a least common denominator is going to have something to do with these two denominators that we're looking at.
Yeah.
In other words, they're not going to give you something that wouldn't make any rhyme or reason. And the key to these is usually factoring.
Yeah.
Let's factor the left.
Oh. Okay. So we're going to factor the left side first?
The left denominator. I can't factor the numerator, but I can factor the denominator. What's the greatest common factor you can remove?
The x.
Okay, so it becomes x times x squared minus 4.
And then that's the difference.
It is difference of perfect squares. I'm not going to factor it yet further until I factor what's on the right.
Okay.
Let's see what ends up on the right. Well, clearly we need a 3x and an x. Signs have to be opposite.
Okay.
And I need factors of 8. Well, if I do 4 and 2, that produces the proper middle term.
Yeah, and it would be negative 4 plus 2, right?
I think it would be...
Oh, the other way.
No, you're right. You're absolutely right. It is negative 4 plus 2. So it's 3x minus 4 times x plus 2. Let me erase what I had mistakenly written. Now, let's go back to the left, and we realize that I can factor x squared minus 4 into 2x minus 1 over x times x minus 2 times x plus 2.
Yeah.
And that's my denominator, or one of the terms is my denominator on the right.
Okay.
So, in order to subtract these two terms, I have to have a common denominator. I'm subtracting that from that. What is my common denominator going to be?
Sorry, you're subtracting the 2x minus 1 minus the 1 over...
Yes, sorry for its appearance.
Sorry, I was writing on my paper too. So the greatest common factor, would you...
Well, we're looking for the least common denominator.
Least common denominator.
Yeah, because I'm subtracting two fractions. They both have different denominators. So in order to subtract them, I need to come up with a least common denominator. Now, normally, if I multiply the denominators, that's the least common denominator. But in this case, I have an x plus 2 there and an x plus 2 there. So I only need one x plus 2. So
you can...
common denominator is going to be x minus 2, x plus 2, 3x minus 4.
And then that's going to be over or under 2x
Well,
minus
let's
1,
get to
or
that in a
2x.
moment. Let me tell you a little
Okay.
secret trick that I have that makes sure that you don't make mistakes.
Okay.
The secret of math is to be checking all the time. Okay?
Okay.
So I need to figure out what to put there such that I do not change this fraction.
Okay.
Well, I clearly need a 3x minus 4
Mm-hmm.
and a 2x minus 1 in parentheses. Now, let's look at that for a second.
Yeah, why do you...
How can I tell that I haven't changed the fraction? In other words, I want to make sure that this fraction here is identical to this fraction here.
Well, you got the 2x minus 2x plus...
Well, notice the 3x minus 4 would cancel with this 3x minus 4. So,
yeah,
could do that, and what I'm left with is what I started with.
Wait, where did you get the top 3x plus 4?
Because the whole point of the game is to not change the fraction.
So you just added that.
A common denominator, but I'm trying to not change the fraction. Well, the fraction was 2x minus 1 over x times x minus 2 times x plus 2.
Okay.
Well, that's that part right there.
Yeah.
But my common denominator needs a 3x minus 4 in it.
Mm-hmm.
So I've got to put it in my numerator also.
Okay.
Okay. There's a more sophisticated way to figure that out, but this is a pretty darn good way, because this way allows you to check and make sure that that fraction is exactly the same as that fraction. And I can tell that it is because the 3x minus 4 would cancel and I would be left with the same fraction.
Okay.
Now let's do the same thing on the right side. What do I need to put up here so that I do not change that fraction?
Wouldn't you have to put so on the right side you have to put the 3x minus 4 and x plus 2 on the top, right?
Well, hold on. I don't need the 3x minus 4. I've already got it in the denominator. So what I need is x times x minus 2.
Okay.
Notice that x would cancel with that x minus 2 would cancel with that, and I would end up with 1 over that, which is what I want.
Okay.
In other words, my goal is to never change the fraction, just write it differently.
Okay.
Okay? Now, now I can say that I haven't changed anything. I've got this fraction minus this fraction, and they're the same two fractions that I started with.
Yeah.
Now, I have my common denominator, and I want to operate on the numerators. So, let's write it now. Here's my common denominator. And you know what? In general, you never want to multiply these together. Just leave it in factored form, because you never know what you're going to end up with in the numerator. I might end up with one of these factors in the numerator. Well, first of all, FOIL those two together. What do you get?
You got 6x squared, and then you got 8x, right? Plus or minus 8x, and then negative 3x minus 3x.
I get that.
And then, oh wait. Oh yeah, because you combine them. Okay, and then yeah,
I just do both of those in one step.
Yeah, okay.
Okay. Now combine the right side, and before you combine the right side, very important to put the full parentheses there.
Okay.
What goes in the right numerator?
The right numerator, would that be the 1?
Well, multiply those two together. That's all it is.
Oh, so it's x squared minus 2x.
Yeah, but notice why I put parentheses around it. Because it's a negative sign right there. So
Yeah.
when I go to remove those parentheses, it changes the sign on the minus 2x, and it becomes a plus 2x.
Okay.
Okay? And that's really important. Without the parentheses, I get the wrong sign on my plus 2x there. So
yeah,
I'm going to remove the parentheses. Hold on. Then it changes the sign to plus 2x.
Yeah.
Now, simplify the top. How many total x squareds do you have?
7.
You got 6 minus 1.
So it's 5x squared.
Okay, how many total x's do you have?
Negative 9. X.
And what's the total number?
Plus 4.
Okay.
And then, do you have to factor that?
Well, I probably would try to factor that just to see that if I get a factor that matches one of these factors in the bottom. Well, let's try. Let's see. We're going to try to factor that. So clearly, let's just see what happens. The only way I can split the x's up is that way. Signs have to be negative, negative. And yeah, 2 and 1 don't work.
Nope.
I want factors of 4. 4 and 1 work perfect.
Okay.
Okay. Unfortunately, that doesn't help. In other words, now I've got this. 5x minus 4. This is my new numerator.
And then x minus 1.
All over my common denominator. Now, this would have been a much better problem had they allowed us to cancel something else out, but they didn't. That's my answer. In other words, had this ended up being x minus 2, then I could have canceled it with this x minus 2 and simplified it.
Okay.
But there's nothing to simplify. What I have circled is fully simplified. There is nothing I can cancel. There's nothing I can simplify. In other words, the only way you can simplify is if one of these two terms is equal to one of these 4 terms. And it's not.
Okay.
So I'm a little disappointed because it would have been a much better problem had they made it so you could cancel something out.
Yeah.
But as it stands, that's the proper answer.
Yeah.
And the question is, should you multiply the bottoms and tops together? No. Factored answers are better than unfactored answers.
Yeah, okay.
Okay? The reason is you never know what the next step's going to be. Maybe the next step is multiply it by x minus 2. I don't know, but the only thing I know for sure is that I'm going to be better off if I have unfactored answers rather than factored answers. Excuse me.
Okay.
Factored answers as a rather than unfactored answer.
Okay.
You always want to leave it factored. Now,
well,
why
shall we do another?
Why would they start us with such a difficult problem that doesn't simplify very much? Well, I don't know. I guess because it's honors algebra. No, seriously, they tend to go out of their way to make stuff more difficult and have it not simplify very nicely.
Yeah.
I guess they want to teach you that not everything comes down to, not everything simplifies perfectly.
Yeah.
All right.
Well, I can see right there that's another like the 2 squares, negative 4x squared plus 36.
Very good. So, in other words, this is 36 minus 4x squared, which is 6 minus 2x times 6 plus 2x. Right? Is that what you were saying?
Wait, is that how you would write it, or would you write it?
It would be, because
Oh,
this is
it does
actually,
not.
notice that this is 36 minus 4x squared. And if I'm going to
Yeah.
call it difference of perfect squares, that's the difference of perfect squares there. So I'm going to factor it by the square root of that minus the square root of that times the square root of that plus the square root of that.
Okay.
Okay? So
And then
let's cross that out and leave this as my denominator.
okay.
Now
You can pull the 2 out of the denominator on the left side too.
yeah, I'm not sure we want to yet, though. Let's talk about something else. What is this equal to?
Zero?
Negative 1.
Oh, negative 1.
Yeah. In other words, if I had 3 minus x all over x minus 3, that would be negative 1.
Okay.
Why? Because b minus a, if I have a minus b, I can write b minus a this way. Agreed? That's the same as b minus a?
Yeah.
Now I can cross off that with that, and I've got minus 1.
Okay.
So this is the one difference. In other words, normally the only way you can cancel stuff is if it's identical, right? Most every problem you deal with has identical stuff, and that's when you can cancel it. Well, notice that 2x minus 6 is the negative of 6 minus 2x.
Okay.
Okay? That's going to make a difference. Not yet. In other words, it's rare that I see it in the denominator like this.
Oh, I know what you do there.
Okay?
You factor out the negative 1 of the 2x.
Yeah, exactly. In other words, I'm going to make this look like minus 2 over 6 minus 2x. Same fraction.
Oh, I thought you were going to do it to the other side on the bottom.
Well, you could do it to either side.
Yeah, okay.
But now it makes it quite simple to figure out a common denominator. What's the common denominator?
6 minus 2x.
Times 6 plus 2x.
Yep.
So I'm going to write that in both denominators because I want to be checking, make sure I don't make mistakes. Now, what goes here?
Would that be minus 2?
Times
5x minus
6
7?
plus 2x.
Oh, yeah.
Notice why that's the same.
Yeah, why? Oh, because...
What I'm trying to do is rewrite that fraction with a similar fraction that's exactly the same, only has my common denominator. Well, my common denominator has an extra 6 plus 2x, but that will cancel with that, leaving me with what I started with.
Yeah.
That's what I mean by always be checking. Is
So
by doing it this way, this might be a little different than the way you've done it in the past.
yeah.
This is a little different than the way I used to do it in the past. A student kind of introduced me to this, and I saw the advantages of it. And the biggest advantage is that you can check and catch mistakes. So what goes on the right side numerator?
Would it be 5x minus 7?
That's it. In other words, my whole goal is to not change that fraction. Okay. Now we have a common denominator. We can operate on the numerator. So first thing, I'm going to distribute the minus 2. So I got minus 12 minus 4x plus 5x minus 7. Combine all of those and you get x minus 19 all over our common denominator. Again, I leave it in factored form, just in case I've got anything in the numerator that could cancel out with that. In other words, maybe I've got 57x minus 19. Well, that wouldn't quite do it. But in other words, if I've got something in the numerator that I can divide by one of these factors in the denominator, then I'm going to be able to simplify it. But I don't. They're not making these easy. They're making these so that you end up with very complex terms, which is fine. It's fine. But it turns into a little better problem if you actually can factor it further and simplify it, because then all of this algebra you go to helps.
Okay.
Okay. In this case, what I have circled at the bottom would be the final answer.
Okay.
And even though you could put the denominator back together and make it 36 minus 4x squared, there's no need to do that.
Okay.
Like I said, leaving it in factored form is generally the better way. All right, hold on a second. Let me make sure. Ooh. That was number 6, right?
Yep.
All right, let's look at 7. We have a over, factor that. I'm not even going to write it because it's a quadratic. I know that I'm supposed to factor it.
And you pull it, so it's a.
The next step I do is to figure out both signs. Both signs have to be negative.
It's minus 3 minus 2.
Okay. Now, what's my common denominator?
Minus 3, a minus 3.
A minus 3 times a minus 2.
A minus 3 times a minus 2. Do you have to FOIL that?
Multiply them together, basically.
Yeah. Okay.
In other words, when I'm finding a least common denominator, what I'm doing is finding a common denominator that is divisible evenly by that and that. And I've got it. I don't need to multiply the a minus 3 times the a minus 3.
Okay.
But I do need to multiply the a minus 3 times a minus 2, because that's the only thing that makes this term divides evenly into the denominator.
Okay.
Okay. The general practice is you multiply them together to get your common denominator. But if one of the linear factors is the same, you don't need to duplicate it. In other words, I don't need a minus 3 squared.
Okay.
Goes in the numerator on the top left.
What goes there?
Uh-huh.
Would it be 1 and then a minus 3?
Just
Or
A.
a minus 2?
Just A. Remember what our goal is. Our goal is to not change the fraction. We're trying to write it with the least common denominator, but we want to make sure it's exactly the same fraction.
Okay.
What I've written is exactly the same fraction. Now,
oh,
okay, what's this denominator? Or what's this numerator over here?
Well, then that would have to be 3 and then a minus 2, right? Because you're keeping
That's
them
exactly right. And notice the advantages of doing it this way. In other words, rather than multiplying a minus 3 times a minus 2, if I leave it in factored form, it's easier to tell that I have not made a mistake, because that a minus 2 would cancel with that, and I would be left with what I started with.
Yeah.
That's always the goal, is to make sure you don't change anything.
Okay.
Okay? Now, to simplify it, I know I have a common denominator that's a minus 3 times a minus 2. What does the numerator become?
The numerator would it be,
You have to distribute the 3.
yeah, so it's 3a minus 6.
Hold on, we got 1a over here, minus 3a, so that gives us minus 2a. But
so it would be 2a minus 6.
It's not minus 6, it's plus 6.
Okay.
Because that minus sign times that minus sign becomes a plus.
Oh. Okay, I see.
Okay. Now, notice how I can rewrite that. This is a good problem, because I can rewrite this as 6 minus 2a. Do you see how I can do it?
Yeah, because you pull out the negative 2, right?
Yeah. Well, I'm just switching the two terms. What I had, minus 2a plus 6, I'm going to write it as 6 minus 2a.
Okay.
The reason I do is because now I can factor out a 2. And I'm left with 3 minus a.
Okay, so it's 2, 3
now, the only reason that's a good thing, let's write it cleaner,
is the 2, 3, or the a minus 3, or 3,
cancel with the 3 minus a as long as I change the sign.
Yeah.
In other words,
so you factor out
I don't need that to be exactly that. If it's the reverse, then that cancels with that, and I put a minus sign there.
Okay, so so say on the bottom, if I factor out the negative 1, then I can put negative 1 a minus 2 over under negative 2.
Yes.
Okay.
Yeah, I don't know that you need to necessarily factor out a negative 1 from the bottom. What you really need to do is recognize that 3 minus a over a minus 3 is negative 1. So I can cross them out as long as I leave a negative sign behind.
Yeah, that's what I was saying.
Okay. And now, if I wanted, I'm not sure the teacher would require it, but if I wanted, I could make that read 2 over 2 minus a. You see why?
Yeah, as long as you leave the negative behind.
Well, I see.
Yeah, because
I've
the
changed
negatives cancel out.
Denominator to 2 minus a, which means I need another negative sign, and the second negative sign turns that positive. So this is that's the cleanest answer you have. And by clean, I mean it doesn't have very many negative signs. This answer has 2 negative signs, this one has 1.
Okay.
They're the same numbers. They're the same expression. is all I've done is change the bottom to 2 minus a, and therefore I have to add another negative.
Okay.
Okay? And that's the reason I said this is a good problem, because it allowed us to simplify it. In other words, once we got to this step right here, I'm not done. I can change. I can take that 3 minus a and work with that a minus 3.
Yeah.
And that's good because it allows me to simplify it. Whereas the previous problem, we couldn't do that. In other words, in the previous problem, I probably don't have it on here. No, I don't. In the previous problem, we didn't have that opportunity.
Yeah.
And I always consider the problems are a little better if you have some nice tricky way of simplifying it at the end.
Okay.
Okay. All right, let's look at the number 8.
Ooh, this looks...
I'm automatically going to factor this. Just partly what I do. I know that these kind of problems, you're always going to be factoring. If it can be factored, you want to factor.
Yeah. Oh, okay.
Okay? Now, tell me what the least common denominator is going to be.
A, right? Would it be a plus 2 or a?
Well, I need a 2, I need an a plus 2, and I need an a. So I'm going to say 2a times a plus 2. Now, to determine whether or not that in fact is my least common denominator, I'm going to try to divide this common denominator by every term. Do I get something even? I accidentally erased something. That was an a plus 2.
Okay.
In other words, I can divide that by a, right?
Yeah.
Can I divide that by 2 times a plus 2?
Yes.
Yes. And can I divide it by that?
I think so.
Yes. In other words, when I say, can I divide it by that, I mean, do I come up with an even number? Do I come up with an a plus 2 or a 2 or an a? Anything that means I've divided it evenly. Okay?
Okay.
And that means that that's going to work as a common denominator. It doesn't necessarily prove that it's the least common denominator, but that's okay. You can solve these problems even if you don't have the least common denominator, as long as you have a common denominator. Now, what goes here?
That you'll, if you're trying to maintain the same...
You are?
Fraction.
Always what you're
trying to do. Would it be 1 then?
Well, notice that it's got to be this. Now, let's talk about how I can get that easier. The way I want to get that number is I want to take 2a times a plus 2, that's my common denominator, and I want to divide it by a. Well, that leaves 2 times a plus 2.
Yeah, okay.
Okay? So that's the technical way to get it. But the way I like to get it is I do whatever I have to write so that I still have that fraction. And notice my 2 and my a plus 2 would cancel with this 2 and that a plus 2, and I would be left with 1 over a. That is the best way to do it because you're checking all along. You've made sure that you haven't changed the fraction.
Okay.
What's the middle term? We know what its common denominator is.
So then it would have to be an a on top. So would it be 2 2 times a plus 2.
Oh, what if I just put a squared?
Because there's 2 a's, okay.
Well, notice that, is that the same as that?
Yeah, it is.
Yeah, it is.
Because,
I could cross out
yeah.
that a and one of the exponents, and I would have a over 2 times a plus 2. Okay?
Yeah.
Now, technically, the way I got that numerator was I divided my common denominator by this denominator.
Mm-hmm.
And I got a. But I got to multiply that a by this numerator, and that's how I get a squared. So whatever I get when I do that division, I have to multiply by the existing numerator.
Okay.
Not sure you necessarily have to do that step. I have found that, boy, as long as you just make sure that that fraction doesn't change, it's pretty easy to figure out the numerator.
Okay.
That to me is the easier way to do it, rather than the more complex way of doing the division. Okay, well, in this term here, I still know my common denominator. What's the numerator have to be?
Would it be a plus, or a times a plus 2?
What is going to make that fraction right there?
Hold on, let me think about this.
Yeah.
Maybe 4?
Exactly.
A times a plus 2?
Just 4.
Just 4?
Notice, yeah, notice that that's the same fraction, right?
Yeah.
Well, that's what I want, is the same fraction. I want this to be the same as what's above it. And it is.
Yeah.
It's exactly the same. Now, how did I get it? Well, I took my common denominator,
Yeah.
divided it by this denominator to get 2, and then I multiplied that 2 by the existing numerator. That's how I get 4.
Yeah.
That's how I get 4.
Okay, thank you.
Okay, because that cancels with that cancels with that. I'm left with 2, but I do have to multiply the existing numerator by that answer.
Yeah, okay.
Okay, but the key thing is when you're done, make sure that each fraction you have written is exactly the same as it started.
Okay.
Now, let's simplify it. It's always a case of simplifying the numerator. The denominator is going to be the common denominator. Now, we got to distribute that and simplify everything. So what do you get?
So you do 2a plus 4, and then so it would be a squared plus 2a plus 8.
Now, that answer looks fine. The only thing that maybe I could do would be to factor the numerator. Because what if the numerator gave me an a plus 2 factor?
Yeah.
Then I'd be able to cancel it. So it's worth investigating whether I can factor the numerator. Well, you've probably figured out by now that you cannot factor the numerator. I cannot find factors of 8 that add to 2. That's what I would have to be able to do.
Yeah, and you'd have to use a quadratic formula.
Right, and the quadratic formula never produces numbers like I've got in the denominator.
Yeah, not a factored number.
There's no point in factoring it if I have to use the quadratic formula. I'm going to get square roots of stuff. Okay?
Yeah.
I'm certainly not going to get anything that can be canceled with one of those terms in the denominator. So the moment I recognize that, the moment I see that the only way I'd be able to factor the numerator is by using the quadratic formula, then that means that's my final answer. In other words, there's no way I'm coming up with a 2a, a 2, or an a plus 2. And that's the only thing that would allow me to simplify this thing further, is if I were able to come up with a factor in the numerator that was one of these factors in the denominator. Since I can't do it, that's my answer.
Okay.
Okay. Boy, they don't give you easy ones.
No,
They don't give you ones that have nice, simple answers.
Yeah.
That's okay. The world doesn't operate in a nice, simple way, so I understand that. Although for learning something, it might be better if you were able to simplify everything. What's the bottom left factor into?
It's going to go 5x plus 3, 5x minus 3.
What's the bottom denominator factor into? Now, one thing you can be almost certain of, just because of the nature of the material, is that one of these factors is going to be the same as one of those factors.
Yeah.
So it kind of helps in factoring it. I certainly know that it's 5x and x, and then my signs are plus, minus, or minus, plus. And now factors of 12. Well, I'm pretty sure my factors are going to be 4 and 3.
Yeah.
See if I can produce 17. Well, 4 and 3 does not produce 17. That produces minus 12. How about 4 and 3 there? That produces plus 12.
Yeah.
Okay? So I don't like those answers. Let's try the 4 on the other side, and I'm trying to produce 17 in the middle. Well, that's minus 3x. That's plus 20x. Bingo. That produces my 17x in the middle.
Oh, okay.
That's always the way I do these. In other words, when I'm factoring hard quadratics, and this is one of them, that's definitely a hard quadratic, then I always need to check the middle term. I'm not concerned about producing the proper first term or last term. The way I factor, I know that when I split 5x squared up, I split it into 5x and x. That's always going to be correct. And when I look for factors of 12, I know that it's 3 times 4 is 12. So I got my first term and my last term correct for sure. The only term I'm not sure of is the middle term. So I do this method that I call the double smiley face whenever I'm dealing with a difficult quadratic. Okay? Just to make sure I've got the middle term correct.
Yeah, okay.
Now,
so you multiply negative. Okay.
Okay, now I'm looking for a least common denominator.
Which is 5x minus 3.
Well, that's one of the terms. Remember that the least common denominator has to be divisible by that, and it has to be divisible by that.
Yeah.
So I got to have a 5x plus 3 also. And I got to have an x plus 4. In other words, it's not quite the product of the denominators, but it's close. Right? In other words, I need to multiply that by that, and then I got this new term over here that I got to multiply it by. I don't have to square the 5x minus 3. because they're the same term.
Yeah.
It's a little difficult to explain, but the key is this common denominator divisible by that?
Wait, which common denominator?
This common denominator down here.
Yeah, divisible by the...
That's what I've determined to be my least common denominator. Okay, so I'm going to write it in both places.
Okay.
Now, to be certain that that is a least common denominator, let's divide that by each of these two terms.
Okay.
Divide it by this or divide it by that denominator, what do you get?
Divide that by that denominator, and would you just get x plus 4 back?
Yeah, so that I'm going to multiply that x plus 4 times the 4, and now I know that that fraction is the same as that fraction. Because I check it. I can just cross off the x plus 4s and I've got what I started with.
Okay, and then for the other side, you would just do 3 times 5x plus 3, right?
You got it. That's the way to do it. In other words, you don't have to actually go through that division process. It's actually, I think, more efficient to just make sure you have not changed the fraction. That's the...
Okay.
You always want to do that step, regardless of how you come up with your numerator. I mean, a lot of people would teach you the formal way to come up with your numerator, and that's fine. But the way I come up with the numerator is I make sure whatever I write there has not changed it from the original fraction. Whatever I have to write, that's what I write. And believe it or not, that's actually a pretty easy way to do it.
Yeah.
As long as you don't combine your denominator. Notice that had I multiplied these three terms together on the lower left, well then I would have had some cubic, and it would have been really hard to figure out exactly what my numerator should be. But as long as I leave it in factored form, my least common denominator, well now it's real easy to make sure that I have not changed anything.
Okay.
Now all I got to do is
add across the top, right?
Yeah. In other words, I'm going to put my common denominator down here. Never multiplying it together because I might be able to cancel something else. What do I have in top?
So it's 19x.
4x plus 16.
Yeah, and then
15x plus 9. So
it's 19x plus 25.
Okay. That cannot be factored. Since that cannot be factored, because 19 is prime, then there's no way I can find a factor there that's going to cancel out with something in the bottom.
Yeah.
Because of that, that's my final answer. The only reason I would ever go forward is if I could factor something out that looked like either that, or that.
Okay.
Then I would be able to cancel it and simplify this thing. But like I said, they're not making these so that they're easily simplified.
Yeah, for real.
Actually, I consider a bad thing. They'd be better if they had made it that way. In other words, why don't they give us something in the numerator that looks like 5x minus 3 times something, and then I'd be able to cancel out the 5x minus 3 and simplify the whole thing a little bit.
Yeah, okay.
There's no way I can pull a factor out of 19x plus 25 that looks anywhere near any of these three things, then I can't go any further.
Yeah. Well,
go ahead. You have a question?
My math teacher's mean.
Why? Oh, just because the nature of these problems?
Yeah.
Yeah, they're tough. I mean, when I say tough, I don't necessarily mean tough. I mean, they don't simplify nicely.
Yeah.
Okay, but whenever you see a problem like this, always know that this quadratic can be factored. And so can this one.
Yeah.
And that's always your first
Okay.
step. Okay, so we got x plus 7 factor the bottom. What do you get?
You get x. Hold on. X, and then would it be 6 and 7, x plus 6, x plus 7?
Right? Okay. Now factor the right side. I'm not going to cross that off yet. Let's just see what the right side gives us.
Okay, and then that would also be x, and then, wait, how it, wouldn't
7 and 1.
7, oh yeah, you're right.
I need factors of 7 that add to 8.
Yeah.
That's 7 and 1.
Yeah, I just had a brain fart right there.
All right. Okay, so what's my common denominator?
X plus 7.
No, remember the common denominator has to be the sum. The common denominator has to be divisible by that and that.
So it would be x plus 6, x plus 7, and then x plus 1, right?
You got it. In other words, the common denominator is always going to be the biggest thing. It's never going to be a small, it's never going to be one of these factors. It's going to be multiples of those factors.
Yeah.
Okay. What's the top left got to be?
It's gonna have to be, would it be x plus 6, no, x plus 7, x plus 6?
No. Notice that if I write it like that.
Oh, x plus 1?
Yeah, because
Oh, what am I, yeah.
that will cancel with that and leave me with the same fraction I started with.
Yeah, you're right.
Okay? All right. That's, I mean, I could go through the hard way of figuring it out, but to me, this is actually the easier way once you get used to it.
Mm-hmm.
Okay? And this over here is x plus 7, x plus 6, x plus 1. What goes in?
And then it would be 10x, x plus 6.
You got it. Now you're getting the hang of it, I can tell.
Yeah. I just need to remember that it's just you put the 1 that's not already in the fraction.
I mean, who gets these hard problems? Nobody.
Yeah.
And I mean nobody. I have not worked with an algebra student that has had this level of difficulty on these problems. So, give me my new numerator. You do have to multiply those two together now because I've got to combine the top.
Okay. Yeah, so it'd be x, so you need to FOIL that, right?
I'm going to speed it up a little bit.
Yeah.
I got 7x and 1x plus 7. And then the key thing here is parentheses. If you do not put the parentheses in, you're going to get the wrong answer.
Okay.
You see why? Because this negative sign gets distributed to both the 10x squared and the 60x.
Yeah, I see that. Okay.
So without the parentheses, I would get a different answer.
Okay.
So simplify the numerator now.
So would it just go to x squared plus 8x plus 7 minus,
figure out how many x squared you have.
2. Or you have 4 x squareds.
They sum to minus 9.
2x squareds. What am I talking about?
What do the x's sum to? And that's a minus 6x.
And so then that would be a negative 52x.
Okay. And then we have a
And then
7. And that's all over this. Now, we don't know that this is simplified because it's possible this thing might factor.
Yeah.
And one of those factors might be one of the factors in the bottom. But after tutoring for 8 years, it's never that simple.
Yeah.
You just don't make it that way. Obviously, the bottom has to have an x, so if I were to try to factor the top, it would have to be x there, minus 9x there. Now the question is, can I produce this plus 7? Well, gosh, I got all kinds of possibilities here. I could do minus 1, minus 7. That produces the minus 7, but it doesn't even come close to producing minus 52. And I'm never getting minus 50. Maybe, what if I did 7 there and 1 there? Well, that gives me minus 54, or rather plus 54 minus 1x, not 54, what am I doing, 63, minus 1 would give me 62, but those are the only possibilities I really have. And like I said, after 8 years, I never am able to factor that quadratic and come up with a factor that matches something in the bottom.
Yeah, okay.
The way I've kind of stopped trying. That's my answer. In other words, if I was taking a timed test, I wouldn't even try the numerator. I would not waste my time trying to factor it.
Yeah.
Just because it never works. They don't give you problems where I can pull a factor out of the numerator that matches something in the denominator. And understand, it has to match perfectly. It can't be x minus 7, it can't be x minus 6, it can't be x minus 1. It's got to be one of these 3 exactly. So it's pretty easy to disprove that one of these 3 could be a factor of that.
Okay.
I just did it, and once you disprove that, well then now you know you're looking at your final answer.
Okay.
All right. Simon, I unfortunately have a 4:30 that I'm 2 minutes late to, so I've got to go, but hopefully I've been some assistance to you, and feel free to schedule another appointment. If you want to schedule online, this is the best website to go to, digitalmathtutor.com.
Okay.
And that will show you my complete availability, let you actually schedule sessions online without talking to me.
Okay.
And that's really the best way to schedule sessions, is because it's very difficult to verbally tell you what my availability is. I mean, what am I going to say? I'm available tomorrow from 10:30 to 11, and then again from 1 to 1:30, and then again from 5 to 6. It's a difficult thing to describe, but if you go to my website, you'll see it laid out in text. They'll show my exact availability and let you pick one of those times if you wish.
Okay.
Okay?
Okay. Here, let me write down this really quickly.
Yeah, I think your parents probably have my other website, which is algebra to calculustutor.com. And you could use that just as easily, but this is a little smoother. This is a little better. This is a little better website.
Okay. Well, thank you.
You're welcome. I will talk to you next time, Simon.
Okay, see you.